Hi, and thanks for joining us for this video on how to monitor Anycast on a BlueCat Bdds with Snmp. Many organizations deploy DNS servers with Anycast as a means to provide a highly available DNS infrastructure. Anycast DNS normalizes the client-facing IP address for DNS. This makes future upgrades and maintenance simple, as the underlying IP addresses of individual DNS servers aren't exposed to the environment. Anycast can also direct DNS queries to the nearest DNS server, therefore optimizing the DNS query path. BlueCat DNS servers are easy to configure for participation in Anycast and can easily be monitored from any Snmp-based monitoring solution. Let's take a look at the lab environment we're using in this video. We have a pair of routers that are OSPF neighbors. We've also got a pair of BlueCat DNS servers on the same network and members of the same Anycast pool. Ultimately, both DNS servers are listening on the same 10.10.10.10 Anycast address. In this example, clients would direct their DNS queries to the 10.10.10.10 address configured as the Anycast IP. We've already configured Anycast on both BlueCat servers. Let's jump over to BlueCat Address Manager and verify the configuration we've put in place on the Bdds at 10.10.10.83. From the dropdown, we can select the routing protocol we're using for Anycast. In this case, we've selected OSPF. After supplying the necessary Anycast configuration parameters, click Update to apply your changes. Next, we'll verify the configuration details we just entered via BAM are active on the Bdds. Note, no deployment is necessary for the Anycast settings to be applied. First, we'll run the IP address command. The results of this command show that a TUN0 interface has been added to the Bdds. Since this interface is virtual, the state will show as down. The TUN0 interface is configured with the Anycast IP address of 10.10.10.10. Next, we'll run a netstat command. This netstat command confirms that the Bdds is listening on both the locally defined IP address and the Anycast IP address on port 53 for incoming queries. Next, we'll use the vtysh command to enter the CLI of the underlying Quagga daemon. The show IP OSPF neighbor command will list all the neighboring devices, in this case, both routers and the Bdds at 10.10.10.81, as well as their states. The show IP route OSPF command will confirm that Anycast is a connected route. The O character at the beginning of each line indicates the route is being advertised by OSPF. Type exit to exit the Quagga configuration. In some cases, certain configuration parameters of your routing protocol may require that a Bdds is placed in manual override mode. Custom configuration options such as OSPF authentication, various area types like NSSA, or multiple BGP peer addresses aren't available to be configured in the BAM UI and require administrators to modify the files shown here. Please contact BlueCat Care for assistance with manual override. Also, note that the default behavior of the Bdds is to monitor the status of the DNS daemon and stop the Anycast daemon if and when the DNS service goes offline. Stopping Anycast on the Bdds removes the announcement from the routers and will prevent DNS queries from being sent to an offline server. Next, we'll poll the Bdds from an Snmp client. When walking the OID shown here, we can see that the Bdds responds with each OSPF neighbor and its status. The status of each OSPF neighbor is represented by an integer value, In this case, a status of 8 indicates full neighboring relationship. Other statuses may indicate some level of degraded connectivity. Now, we'll verify that an SNMP trap server has been configured for the BDDS at 10.10.10.83. Defining an SMTP trap server will cause the BDDS to announce that an event such as a degraded neighbor state has occurred. Here we can see that the BDDS is configured to send SNMP traps to a host at 10.10.10.69. Let's start a packet capture on that host and watch incoming packets to see our SNMP trap arrive. Oh no, it seems a junior network technician has misconfigured a router interface on 10.10.10.73. This error will cause devices in the Anycast pool to inform each other of the change and update their routing table accordingly. We can see the SNMP trap sent by the BDDS at 10.10.10.83 received here on our monitoring server. Once the trap is received, your monitoring solution can be configured to raise an alert. Now, let's check the neighboring state on the BDDS. We'll enter the Quagga daemon by typing vt ysh and run the show IP OSPF neighbor command. As we can see, one of our neighbors is in EX start mode. This indicates the connection is in a degraded state. Finally, let's perform another SNMP walk. This time, we see that the BDDS responds with a status of 5 for the neighbor of 10.10.10.71, the misconfigured device. When any value other than normal is observed during the poll, your monitoring solution can be configured to raise an alert. By leveraging the SNMP protocol to send traps when an issue occurs in your Anycast environment, as well as polling BDDS servers from your monitoring system, network administrators can be alerted when the status of Anycast on a BlueCat BDDS changes. For more information, visit bluecatnetworks.com or contact BlueCat Care today.